Hey class, Mr. Husted here, back for our final episode in Chapter 3. We've talked a lot about parallel lines, and we're going to wrap up this chapter talking about perpendicular lines. So we're going to prove some theorems about perpendicular lines. A couple more theorems to add to your paper, which is probably overflowing by now. We have extra copies for you to add to it. Again, if you want a page protector to just tuck all those in, we have plenty that I can give you in class. Otherwise, make sure they're 3-hole punched and put in your binder. Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Basically, this is kind of like an angle bisector theorem. If this line intersects such that angle 1 is congruent to angle 2, the only way that happens is if both of those angles are right angles, because we have to have 180 degrees. And so if they are equal to each other, the only way that happens is if they're both 90. So that is how we know if angle 1 is congruent to angle 2, then G is parallel to H. Theorem 3.9, if two lines are perpendicular, then they intersect to form 4 right angles. Kind of one of those no-brainer theorems, because we know that they intersect to form a right angle. And if one angle is right by vertical angles, we know that one is a right angle. By supplementary angles, we know that's right, so on and so forth. So if two lines intersect and they're perpendicular, all of those angles are right angles. So let's take a look at example 1. Just want you to draw a conclusion. In the diagram here, line AB is perpendicular to line BC. What can you conclude about angles 1 and angle 2? If they're perpendicular, we already know that angle 1 and angle 2 are equal to 90 degrees. We would also know that angle 1 and angle 2, they are a linear pair. We would also know that angle 1 and angle 2 are supplementary. So just some things that you can conclude just based on looking at those two and knowing that they intersect at a 90-degree angle. Okay, and if you weren't tired of theorems yet, here's theorem 3.10. Two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Again, this line is intersecting this line, and that's perpendicular. Basically, that means that you have a 90-degree angle here, and a 90-degree angle, or two angles that add up to 90 degrees, are said to be complementary. So that's just simply what they're trying to get across to you here, is that if you have two angles inside of perpendicular lines, then they are complementary. So flip the page. All right. I know you thought you were done with them, but we have one last one here. And that is a proof. We are trying to prove that theorem we just talked about, and we're going to do so here with this one, with example number 2. So we are given that ray ED is perpendicular to ray EF. Because of that, we know this is a 90-degree angle. We are trying to prove that 7 and 8 are complementary. Okay, so the very first statement here, just like every other first statement we've had so far, is going to be our given. Statement number 2, angle DEF is a right angle. There's a couple different ways here we know that DEF is a right angle. Definition of perpendicular lines, although we're not talking about perpendicular lines, we're talking about rays, so that becomes slightly different. If you remember back to, this is just on this page right now, Theorem 3.9. And Theorem 3.9 stated that if we have perpendicular lines, then we create 4 right angles. So in this case, we can simply just put Theorem 3.9 tells us that that angle is right. Number 3 here, the measure of angle DEF is equal to 90 degrees. Theorem 3.9 told us that it was a right angle. Step 3 here, saying that it is equal to 90 degrees, is just the definition of a right angle. We know that it's equal to 90 degrees. So definition of right angle. Okay, now we're going to be reaching back a little further here for number 4. Measure of angle 7 plus measure of angle 8 gives us the measure of angle DEF. This we've learned about in chapter 1, and that was our angle addition postulate. Remember, angle addition postulate just said the sum of two smaller angles is a larger angle. Okay, and then we have, instead of saying that it's equal to the measure of angle DEF, we now say it's equal to 90 degrees. So if we look here, we have this statement and we have this statement. They have measure of angle DEF in common, so they cross out. And what's it called when we substitute one in for the other? We'll call it the substitution property. And finally, if 7 and 8 add to equal 90 degrees, they are complementary, and that is just the definition of complementary angles. So again, you thought you were getting out of proofs. Nothing too difficult there, though. We did throw in one of our new theorems there with Theorem 3.9, but that just proves why Theorem 3.10 works.
I'm not getting through the proof. I'm dying!
As you can see, Mr. Brooks may not be with us anymore, as this proof has just put him over the edge. Speaking of over the edge, let's add 2 more theorems to our paper. Yeah, we're getting lengthy here on these theorem papers. Theorem 311, if a transversal is perpendicular to one of 2 parallel lines, it is perpendicular to the other. So basically, if these 2 lines intersect at a right angle, and these 2 lines are parallel, then this also will be a right angle. We know that because of corresponding lines, or corresponding angles. Theorem 312, if 2 lines, or if in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. So these 2 are just kind of like the converse of each other. One tells us that they're parallel, the other one tells us that they're perpendicular. But if we know those 2 things, then we can assume the other. Okay, and then finally, let's just draw some conclusions here for example 3. So determine which lines, if any, must be parallel in this diagram. Okay, so if we have, I'm going to look at these 2 lines right here. I'm going to highlight them so they're a little easier to see. We have this one here and this one here with a right angle. They both have a right angle to this one. Okay, to line Q. So we can say that line S, so S is parallel to T. And then finally we also see that this one, let's highlight, this one and this one are also perpendicular to the same transversal, which is S. So we can also say that P is parallel to Q. Okay, so that wraps up chapter 3. Hopefully you've learned as much as you want about parallel and perpendicular lines. If you have questions, bring them with you to class.